All right, we are on the last practice problem for the conceptual piece on our electric potential energy notes. So for this one, we have some small charge Q. Let me make that one. Right, Q's in there, and it is moving to the right towards some positively charged object. Okay. So if charge Q is positive, so if Q is a positive value, does it speed up or slow down as it approaches the stationary charge? So using the principles of energy and work. So when we're looking at this, right, this is pretty similar, but we have two positively charged charges, and that means that the electric field is going to be moving away, right? So this is our E field in the direction, right? And it's going to be propagating all outwards here. So remember that when we are gaining potential energy, we are moving against the electric field. And notice that our velocity is moving against the electric field. So because we're gaining potential energy, we are going to be losing our velocity. So it's going to be slowing down. We can think about this as for force as well, right? Because it is two positively charged objects, well, the force is going to be pointing away. And this means that it's going to be slowing down since the velocity is in the opposite direction. Again, I want us to think about this as a hill. So let's say that, right, this is it's like a conical hill, and it's going to be something like this, right? And so our charge was going to be rolling up until it comes back down this way, because it is positively charged. So let's think about B, since A is pretty similar to number 2. Does the magnitude of the acceleration of Q increase, decrease, or remain constant? Justify your claim with evidence and reasoning. Well, I can already see from my hill that it is curved, which means that my acceleration as it gets closer is going to be more than when it's over here, right? This is my acceleration vector, or my force vector, right? And we know that force is related to distance for electric charges. So as we get closer to the object, the repulsive force is going to get greater. Now, same thing is going to be happening with our energy portion. Since the electric field is going to get more dense the closer we get in, well, that means that the force is also going to increase the closer we are to the charge. And the greater potential energy we're going to be gaining per centimeter or per meter, right? So does the magnitude of acceleration increase? Well, yes, it's going to increase as we get closer, and then it's going to decrease once we start moving away. All right. And then lastly, we have part C. So what's going to happen if we flip this charge? So what if this becomes negative? Right? What if we flip our charge? Well, then, what we're going to do is we're going to flip everything, just like we've done in the past. So the electric field now is going to be going inward, or sorry, the electric field is still in the same direction because the charge of the object stays the same. But the forces here are going to flip because now the force is in the same direction as the velocity. And then we can consider this now like a well. So we flipped our hill, it's upside down. So now our charge is going to be rolling faster and faster and faster down this hill. So does it speed up? Oh yeah, it does. It doesn't slow down because now we have an attractive force and our potential energy is now a well instead of a hill. Does the magnitude of the acceleration increase? Well, yes, it does, because we still have a hill, we still have a curving hill, but now it is towards the charge. Okay. I hope this helps us understand how changing charges changes either force and the energy. And I will see you in the next video.